I felt like we could just do the same thing.
Got to set it up? What'd you get?
Not really.
Sort of?
I don't know. I tried to do like Punnett squares, but I don't know.
Okay. So it's two genes, right?
Uh-huh.
So you call A and B, okay. Heterozygote for both. That makes sense. And then we're looking for 8-pound pumpkin. So how would you have what genotype would lead to an 8-pound pumpkin?
2 dominant alleles.
2 dominant alleles, okay. So what genotype combinations of those 2 genes would have 2 dominant alleles? That's what you're looking for.
Okay.
Yep. Hello. What we got?
Okay, so I'm thinking this is wrong because I think it isn't like a bigger box.
You could do it with that way. If we're gonna do A and B together, then you have 2 genes, heterozygous for both. So the genotype of individual would be like that.
Okay.
And then the other parent would be that.
Okay.
So if you want to do them in the same box,
It would be like.
it'd be like 4 possibles and then 4 possibles.
Okay.
Yep.
So it would look like this, right? It'd be like A, B, A, B, A, B, A, B.
Yep. Exactly. Mhm.
That room? Yeah. Oh yeah, I got that.
Hey yo.
Hello.
We got
What's it?
1/4. So because
4. How'd you get it?
so in order to have 8 pounds, they both need to be dominant, right? So they're both heterozygous, so AA, BB. So
Okay.
this one will give you 1 because all the other ones will either be heterozygous or recessive. So those will be 7. That would be 6, right?
Uh-huh.
And then the same for this. So 2 out of the 8. So 1/4.
What if they were heterozygous for both genes, though?
Then wouldn't it be 7 pounds because there's only 1 dominant?
Well, there would be 1 of each. 1 big A, 1 big B.
Oh.
Right? That would also be a potential combo. So looks like you got some of them, just not
Okay.
quite all of them.
Okay.
Hello. What's it got?
So what we're thinking is that because they're heterozygous and they have 1 dominant, we're thinking that if it starts with 6, that would add, the parents would be 8 pounds. So then we just cross them. Thank you, good catch. We cross them, and then 1/2 would be heterozygous, 1/2 heterozygous. So then we just multiply those. But we were thinking that was too easy, so we don't know for sure.
A heterozygous and a heterozygous? Okay, I got you. So being a heterozygous for both the A gene and the B gene, that's one way you could have 2 dominant alleles. You could also have, let's say, 2 dominant A's and no dominant B's though, right? So I think you got some of the possible outcomes, but just not all of them.
Okay.
Yep.
Thank you.
Yeah.
Could you explain the difference between like this and this? Because they have to sound like the same thing.
The difference would be where the gene is located. So in the autosomal dominant, every individual has 2 copies.
It could be that.
And having at least 1 dominant allele, you'd have the trait. For X-linked dominant, the gene is on the X chromosome. So females have 2 copies, but males only have 1 copy.
Having one of these at the pound.
So it has a different pattern to it.
Gotcha. Okay.
For example, if you had a male with an autosomal dominant trait
They're supposed to be heterozygous.
and he was a heterozygote, he'd have a 50-50 chance of passing it on, right?
Right.
But if he had a daughter and it was X-linked dominant, she would have to have it because he only has 1 X.
And then I think you could also do.
So you see a different pattern with those 2.
Gotcha.
Yep.
Thank you. Goes 160.
I'm very confused. Like usually
Okay,
I feel
okay.
like I'm able to like start, but I just like I did the Punnett square. I guess like how do I know that it would be 8 pounds?
Well, first of all, there's two genes. So R would represent one gene, but then you also need a second gene.
So I could do like
Any letter, yeah.
like
Okay. And then, so it says the two genes together determine the trait. 6 is the smallest pumpkin, 10 is the largest.
would like 6 pounds represent the recessive? Like
That would have to be recessive for both genes, right?
yes.
And that would give you the smallest possibility.
Okay.
And then every dominant allele in the genotype gives you 1 more pound.
Okay.
So 10 pounds then would be all dominant alleles. Yep. So you can kind of set up a scale.
Okay, and then this would be would that be 8 pounds?
Well,
Or
for both genes, sure. But between the two genes, there has to be 2 dominant alleles.
oh okay. I see what you're saying.
Yep. All right, we are almost finishing up this one here, so give you about 15 seconds, and we'll take a look. All right. Okay, here's our vote. Majority of the class going for B. Also had a decent number of votes for A as well. So maybe a little bit difference of opinion there. Okay. Let's take a look at this one though. We got a 2 trait, 2 gene situation. I don't know, I'll call my genes A and B, I guess. And the plants involved in the cross are heterozygous for both genes. So basically, that crossed with that. And so doing a cross like that, you know, we've done quite a few times. You can just kind of look at the genes individually. It'd be the same for both A and B. If you wanted to draw a Punnett square, you could do that. And those would be your outcomes. However, we're being asked, offspring with 8-pound pumpkins, what kind of genotype would we be looking for 8-pound pumpkins? We need something to go off of here. It says our pumpkins range from 6 to 10 pounds. So the smallest one is 6 and the largest is 10. And that's being determined by how many dominant alleles there are. So what would the genotype be for a 6-pound pumpkin? What's that? For 6 pounds. Yep, smallest possible. No dominant alleles, right? They would have to be basically that. So 6 pounds would be no dominant alleles. 10 pounds is the largest, which would have to be all 4 dominant. So you can kind of set up a scaling factor there where each dominant allele adds 1 pound to pumpkin size. We're looking for 8-pounders, which would correspond to having 2 dominant alleles. What kind of combinations are going to give me 2 dominant alleles? Could be 2 dominant A's, would be 2. It could be 2 dominant B's, or maybe a heterozygote for both genes. It's only 3 I can think of. So we just need to look at our crosses then. We got a quarter chance of that, and a quarter chance of that. Or means add, right? Our probability rules. That's a quarter. That's a quarter. And heterozygote would be a half. And a half. So that would give me 1/16 plus 1/16 plus 1/4. Then I got to work with fractions. 1/4 is 4/16. 5/16, so 6/16 would be 3/8. So B would be right. For the 1/4 answer, which was another common answer, I think most of the group, based on what I talked with groups, I think had some of the genotypes for the offspring, just not quite all three possibilities is where that answer came from. So close on that one as well.